Hello everyone, it's Kevin here again, and we're going to go over some C# basics. So this class has a prerequisite of C# 1, so most of this stuff should just be review. So we're going to start off with variable assignment. We use equals to assign a value to a variable. So we're going to assign 100 to variable x, pretty straightforward. We have our comparison operators, so equals, greater than, less than. This is our review. Logical operators, this is for our and then this one here is for our or. So if 1 and 1 returns a 1, 1 and 0 returns a 0, 0 and 1 returns a 0, 0 and 0 returns a 0 with our or. Similar deal, except of course it's the or operator, so 1 or 0 returns a 1, etc., etc. Not is just it's just gonna return the inverse of whatever we pass into it. So we pass in a true, it's going to return a false. Pass in a false, it's going to return a true. We're going to have, what we have here is we have some variables and types. So I declared a couple variables here, and they're of a couple different types. So we have our string variables, characters, integers, doubles, and our constants that we're going to go over quickly here. So trying to assign a different value to a constant during runtime is going to throw an exception, so we don't want to do that. Once again, some more review. Control structures, if 1 equals 1, well, 1 equals 1, else 1 does not equal 1. Let's look at some of our IntelliSense here. Unreachable code detected. So it notices that this is always going to be true, so it knows that we're never going to hit this here portion. It's a pretty neat feature from Visual Studio. And what we're going to do here is we're going to take some user input. So we're going to ask for the first integer and then the second. So we're going to take that string, we're going to assign this string the value of whatever the user inputs, and then we're going to declare our integer that we're going to parse that value into. So we're going to try to parse it, and if we look over here, it returns a Boolean. So if it gets parsed correctly, it returns a true, otherwise it's going to return a false. So it takes in a string, and it outputs, it returns the, it's going to return the Boolean, but it's also, what it's going to do within here is it's going to assign the value of the string, the parsed string, into whatever we set here as the parameter. So what we'd expect it to do here is we'd expect it to convert the string into an integer, and if there's any sort of issue with that, it's just going to return a false. So it's just going to go past this, not going to throw an exception. We're going to be golden. Same thing with the second, and we're going to try to parse that. So if the first integer is greater than or equal to the second integer, we're going to rate this. Else, if the second integer is greater than the first integer, rate this here down. Else, we're going to rate down this here. Else was hit. So we're going to get into some debugging tools of Visual Studio. So I'm going to set a breakpoint right here wherever it lets me. There we go. It's going to let me set it right there. We're going to try looping through here. The expected output is, we have, if 1 equals 1, we're going to have 1 equals 1, of course. Then we're going to ask the user to enter the first int and then the second int. So we're going to run through this. Looks good. 1 equals 1. Enter the first int and then the second. So we're going to enter 1 and then 2. And the second is greater than the first. And greater than or equal to the first, which is true. The second is greater than or equal to the first. It's not the other way around. So once again, straightforward, nothing new here. Now we have their ternary operator. So I'm going to stop the program here, and I just have a Boolean variable called bigger, and the value of bigger is going to be it's going to depend. So if first int is greater than second int, the value of bigger is going to be true, and if this here is not true, then the value of bigger is going to be false. So is first int greater than second int? Well, let's think about this. Why don't we run through this, first and second value, go back to our output. So second is greater than or equal to first. We're doing good so far. So let's think about this here. Right here we have it. The value has been assigned, the value of false has been assigned to this here variable. Why is that? Well, is first int greater than second int? No, it's not. So we can't assign true to this because this here condition is not true. So we're going to, the right side of this here operand is going to be assigned into this. So keep this notation in mind, because there's a couple other operators that we're going to be using in C# that are pretty similar to this. So that moves me on to the next concept, and I'm just going to go ahead and step over this here so we can see. Yep, it's false, so it's just a two-string representation of this here variable. So we can make a variable nullable by adding the question mark after it. So normally you can't assign a null type to an integer or just about any other primitive, but by adding that question mark, it makes it nullable. So that allows us to use some pretty interesting features, some pretty interesting operators here. So right here we have a nullable string, and that string is going to be, it's just going to be string A, and since it's nullable, we're going to assign null to it. Nullable string B, on the other hand, is going to be assigned an actual string, and the value of it is going to be the literal value is null ... So what we're going to do here is we're going to use the null coalescing operator. What the null coalescing operator does is it compares the left and the right operand. If the left operand is null, then the value of the right operand is going to be assigned into the variable that's being assigned here. If not, then it's just going to assign the left operand to the variable that it's trying to be put into. So why don't we just run through this, and then I'm going to go over some possible use cases for the null coalescing operator, because believe me, it's used not super extensively in production code, but it is used in production code. I've seen it various times, and it's worth mentioning. So what we would expect here is when we try to assign the value of A into our string is null, it's going to do its comparison, and it's not going to work. Well, I shouldn't say it's not going to work. Since the value is null, well, we can't put that into our string. It's going to throw an exception. So with our null coalescing operator, it's going to assign value is null into string is null, and we're going to print string is null. So I'm going to add a breakpoint here. We're going to go ahead and jump through this. So go through that. So let's look at our watch list. Run through this again, and then one more time. So is null has a value of value is null. A here is null, and then B here has the value of value is null. And we're going to print the value of variable is null. Step over and look at it here, false. Let's look through here. Okay, it ran through the rest of the program. Let's look here. There we go. Value is null. Sometimes it can be a little funny where if you click on the console, it's going to not add it. It's not going to print out any more output. It'll just stop. So you can just add just hit any key and it'll go back to normal. So where can we use this? You might be thinking, why in the world would I need to check if a value is null? I'll just make sure that the value is never null, and I'm never going to run into an issue. And you know what? That's going to be true for a lot of these smaller programs. So you can just make sure that you never enter in a null value into these variables that you're trying to read and trying to assign values to, and you're never going to run into an issue. And you can also use try-catch blocks. So if they do end up adding that value into it, well, then you're good to go. The try-catch block captures that issue. Where this comes into play a little bit more is with database. So when we try to read some values from a database, we might have an instance where it's a car dealership and they store their customers' names. So we might have a 18-year-old customer that for some reason doesn't have a vehicle yet, but they're inquiring about purchasing a new vehicle. So they're going to be stored in that database, and each individual in this database is going to have a column where do they have a car, yes or no, or maybe not even a yes or no. What car do they have? What's the model of the car that they have currently? But if this 18-year-old individual doesn't have a car, what are we going to put in there? You could go ahead and put no car. You could put something else in there, but more often than not, you're going to put null in there. You're not going to put anything into it. There's not going to be any value inside of that little section. So when we try to pull those values out of that database, and we try to assign those values to some of our variables here, well, it's all right. it's not a problem. We have some nullable variables here, but now when we try to when we try to work with these here variables, it can end up being kind of a mess. It can end up being kind of a mess when we try to access null variables, and that's why if we're trying to add some values back into the database, it's a little bit of a better idea to just have a default. So you could do an empty string, you could do a customer does not have a vehicle, whatever it might be. And you got to remember that a lot of the programs that you write aren't going to be strictly for data access. So you might be writing a script in C# that is going to be fixing a database. So say they're trying to move their database from one version of normal form to another. So by doing some of these operations here, so if we take some of these values that are null within that database and we put a default value into there, we can run a script that wherever the value is null and another condition is met, for example, we're going to put into that portion, wherever that's stored, we're going to put into that little portion a string saying the value, or this person doesn't have this, or this person meets this condition. There's just a million different ways where you can use this null coalescing, so that's why I bring it up. So now we're going to move into repetition structures. I'm going to declare an integer here, integer 1, assign the value of 0 to integer 1, and once again this should be review. It's just like Java, and right here I'm just going to increment that value of integer 1 by 1 each time that it runs through this, and while it's less than 10, we're just going to keep running until it hits 10, and then it's going to stop. So since this is it's not a do while, we would expect this to run. We would expect the output of this to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10. So why don't we test to see if that's true? Add another breakpoint here. Let's look at our output right now. Value is null, good to go. Okay, we would expect 0 through 9, and exactly as we would expect, there we go. Here we have our for loops. So not only am I going to go over some basic for loop stuff here, I'm also going to go over some more debugging stuff, and this is where this debugging stuff really pops out and where it really shines. So just like in Java, we're going to start off with our integer that's been initialized, in this case 0. So we're going to start at 0, and we're going to go, while I is less than 10, we're going to increment I by 1 each time. So why don't we try running through this? We're going to continue. There we go. So what's the value of I? Well, the value of I should be 0 because we're going to start at 0. If we look here, we need to go over this one more time. There we go. 0 has been printed. So if we got to loop through any sort of class or list or anything, this is where it can be useful, where we're trying to track down and pinpoint errors. So we can go ahead and step over, and now we have 1 stored in here. Once again, same deal. 2 should be stored in there. It's pretty neat. I think it's pretty neat, and in production code, when you're debugging production code, it's very useful. So just get used to it. I'm going to get rid of these here breakpoints just because we don't need them anymore. Because if for any reason I have to go and restart the program, it's going to be problematic. So we can also see where all of our breakpoints are here. So if we add a couple other breakpoints, we can see them right here, and we can just shut them off right there. Or we can completely shut them off like that. Pretty neat stuff, I think. Arrays and lists. So we can have a character array here, store A, B, C, and D inside of this character array. Integer arrays, same deal. Double arrays, same deal. But now we can introduce the concept of a for each. So I'm not 100% sure if you all went over this in your previous course, but for eaches, they simplify for loops, and it makes it a lot easier for us as developers to loop through a list. So right here, for each, just read it in plain English, for each character within this character array, do this here, complete this here task. So why don't we run past that? So what we would expect to see here is it's going to print out every single character in this array of type character. So why don't we see if that holds true. Continue. Why are we not continuing? I'm going to get rid of that. I'm just going to restart the program. Let's look at our output. And it looks like I put my breakpoint right at the end of this at the end of this here repetition structure. So I'm just going to put another breakpoint here, and if it lets me continue, not sure why it's not letting me. I'll just go ahead and skip past that. A, B, C, and D. So it did exactly what we expected it to do, but now we have the advantage of not running into out of bounds exceptions. So we're not going to reach into a portion of the array that doesn't exist, which is pretty neat. It saves you time, and it saves some headache, and it gets rid of some weird bugs in your programs. It really is neat to use these for eaches. So as I explained here, arrays are a little harder to work with because we can run into those issues where we run to those out of bounds exceptions, or once you set a size for an array, we have to create another array of a different size if we want to make that array size different, which is very inconvenient if we think about it. So what we can do is we can use a list. So right here, for example, I'm declaring a list of type string called SLI, string list, and all of the necessary code after that to declare a list. But now instead of doing this weird stuff, which we can still do, and I'll scroll down and show where we do that. So right here where we assign some values to the list, we can still do something similar to that, but we can do something that's a little bit easier and just use a function within of the list object there, and it's just an add function. So it's really neat. So we can just add this here string to this list, first word. So we're going to go ahead and just run through this. First word, we're going to add a phrase here, we're going to add a queryable string, we're going to add Dogecoin to it, and now we're going to run into another operation here. So our list.remove. So this should remove this here portion of this here element in this list. So I'm going to stop the program, get rid of this here breakpoint, and let's look over what this does. So it removes the first occurrence of the specific object from the list of type T. In this case, it's the list of type string, and returns true if the item was successfully returned, if the item was successfully removed, otherwise false. So it's very useful. So now instead of having to sort that list and doing a binary search, if you want to be efficient, a binary search. If not, you can just go and do a slow search and just check each element of the array, and it's going to be inefficient. And why do that when we can just use a list.remove? So what we're going to do now is we're going to go over some link/lambda expressions. So we're going to create a new variable here, a new string variable here called queryable string. So what we're going to do here is we're going to use another function that comes with the list object. So it's pretty neat. So what we can do here is, just like these other ones, you notice how they return. This one here doesn't return anything. It just adds the value and then that's it. But this one here returns a true if an item is successfully removed, otherwise a false. What this here function does is it's the find function, and this here is link. This here is just the link notation. So we're gonna find if any value within this list meets this here condition, we're going to assign the value of isFound to true. And we're going to run through this. So go ahead and start this here application 1 and 2. Look at our output. Looks just like what it looked like the last time. So right here, this is not going to have any sort of, it's not going to have any value, so we're going to step over. So is queryable string inside of this list? Well, let's find out. And yes, it is. It is found. So it did find a value inside of it, and that actually assigned isFound, the variable isFound. It assigned it the string that we were looking for. So the point here is that it was found. This here check is going to check if it's null. If it's not null, we're going to write down the string and then the name, whatever string we were looking for is in the list of type string. So we're going to write that down right there and move on. It's going to skip this because we're just not going to hit that. It's not a condition that we end up hitting. So why don't we try something different here? Why don't we try this, change this here to queryable without the E. Why don't we try running this again to see what the output of this function is now. So we look here, enter our values. What is found? It's set to null. So if it's not null, well, we're going to say that we found it. But if it is null, we're going to skip over this, go into our else block, and if we look at our output, it's not present. So yeah, it's pretty straightforward. It's very neat to use this here notation. It'll save you a lot of time. And why go and implement a merge sort or your bubble sorts, which are inefficient, or your radix sorts, or any of these crazy sorting algorithms, and then go and write methods for a binary search when we can just use link. It's easier. We're developers. None of us here are likely computer scientists. We're all developers here, so we want to develop applications for our customers or our employers to utilize. And we can do this efficiently and quickly by using link. So that's why we're going to use it. So what I'm going to do here now is I'm going to go over some more link that we can do here. So I'm going to create another list here called lint, list of type int. And I'm going to add some values here to this list. And we're going to print the unsorted list. So we're going to go ahead and do that. Look at that, and it's unsorted. Then we're going to assign lint. Since it's a list, we can change the value of it, no problem, no issues. We're not going to run into anything as long as it's of the same size. And even if it's not, we're not going to run into an issue either because it's a list. We don't have to worry about the issues that we'd have to worry about with arrays. So we're going to assign to this here variable the ordered list, and that's going to get converted to a toList because its output is not a list. So why don't we stop here and look at what the output will be. And the output of this is an I ordered enumerable. So it's an enumerable, we can enumerate through it, but an enumerable is not a list. So we got to convert it to a list. So let's run through this again. 1 and 2. Hit this breakpoint and get rid of that breakpoint. We don't need to worry about that right now. We're going to sort our list, and if we look here, the value of the list is the sorted list. Pretty neat. And we're just going to run through this via the for each. Get rid of this here breakpoint, and if we look at our output, there's the sorted list, our unsorted list, and then our sorted list. Now we're going to go over some try-catch. So where can try-catch be used? Well, I'm sure you all went over try-catch blocks in Java and probably in C# Programming 1. And you take your user input, and sometimes your users don't give you good input, and it'll break your program. So that's what you can use your try-catch for. Where we're most likely going to, I shouldn't say most likely, the place that we're going to be using try-catch most commonly is going to be in our APIs. So our APIs are going to be taking in request bodies, and these request bodies might contain junk. They might contain JSON that we can't parse. For any reason we're trying to pull values out of another API, and that other API is having issues, or maybe some malicious code was injected into it that we can't deserialize, our try-catch blocks will catch that. And that's where we're going to use it, but you can use it for many other things. So in this example, we're going to just demonstrate a for loop, but if we pay attention here, we're going to try to access something that is not within this here array, because it's numbers.length plus 1. That doesn't exist. So we can tell our IntelliSense already knows that this is going to happen. The IntelliSense already knows, and it's going to advise us, but since we already know as well, we're just this is going to be a teaching exercise. We're going to ignore that. So we're going to run through this. We're going to loop through it. Do this a few times. Should only be 5 times that we get to loop through it. 2, 3, 4, and we threw an exception, but our exception was handled successfully because it was caught in our catch block. So we can just go ahead and skip past that. Alright, we're going to write down our exception, the two-string version of the exception. So instead of having that huge stack, all the stack call and all that other information, we're just going to write down the two-string version of the exception. If we look at that, there it is. Very simple. System.index out of range exception. Index was outside of the bounds of the array. We expected that, but then we're also going to write after that the exception has been handled. And crazy concept here, the program is going to continue running after the exception. If you didn't handle this exception, your program would break. So why don't we just hop past that? And if we look at our output here, program still continues after an exception. Now we're going to get into functions. And if you saw, it just jumps straight past that function because the compiler is going to ignore the function until it uses the function. So functions, just like in most other programming languages, are going to start off with a return type, then with the name of the function or method, whatever terminology you're most familiar with. I prefer function, and then the parameters of the function. So in this case, we're going to have a function that returns a list of type integer, and that function's name is going to be sorted list, and it's going to take in a list of type integer named list. And we'll get into this function a little bit later. If you can tell here, we're pretty clearly sorting the list. So we're also going to create a new list here, another unsorted list. So we're going to go ahead and step through these, and we're going to do our for each and display the value of the unsorted list. Continue. We're going to see our unsorted list here in order. I shouldn't say in order because obviously it's not in order, but in order of the way that we added it. So what we're going to do now is we're going to assign, we're going to create a new list here called sorted list, and we're going to assign to sorted list the return value of the function sort list. So let's run through this. So we're going to go into our step into, and if we look here, our pointer went straight into this here instruction. It went straight to, it went up. Instead of going down, it went up because this is where we have our function declared. So it'll go instruction by instruction. So if we look here into our watch list, notice how we have some locals here, how all of our other locals are gone. Why? Well, this is because of variable scope. These here variables are outside of the scope of this here function. So let's think back to some very basic programming concepts. This is really important because now, say we had another list named list outside of this here function. If we try to access this, the compiler is going to get confused. We're going to run into exceptions. So this is one of the features of the newer programming languages. So if we look here, the only variable within scope is our list of type integer. Look through our list. Looks just like the list that we created down here. Wherever it is, yeah, or it's this one right here because this is where our breakpoint is. And let's see what it does here. So we write down sorting the list, and we return the sorted list. Watch where our little pointer goes to. Goes right back down, back to this instruction. And if we look at the value of sorted list, it should be the sorted list, which is exactly what we would expect. We're going to loop through this here sorted list, and it should display the sorted list. And it does, just as we would expect. So now, I typically don't use dictionaries. I prefer to create custom objects and use my custom objects, but dictionaries are used in production, and one of the learning outcomes of the course is to use dictionaries, and dictionaries are a type of generic. So I'm going to stop the program here. If we look here, system.collections.generic, it's a dictionary, and it uses key value pairs. So think like PHP where you had key value pairs, except here, and I shouldn't say except, in this instance we have it of type integer and then of type string. So our integer is going to be our key, and then our string is going to be our value, and we can access any element within this dictionary based on key or based on value as well. So what we're going to do is we're going to run this here program again, and honestly this is not even going to do anything, just because I'm going to step past this because we don't need that. This isn't going to do anything. We're just going to add some values to it, but we're going to look at it in our local variable watch list. So step past that. We look at our dictionary key value pairs. There's our key value pairs. So we can access those, and if we got to do anything with those, we can do some operations on them. We can sort by key, sort by value, and we can create a list based on the values of this here dictionary, or a list based on the strings, and then do some stuff with those. I prefer the following method here, because this is what is most commonly used with API development. So we're going to get into objects, and this is the home stretch. I'm sure you're excited. This is probably a pretty long lecture video so far. So we have our objects, and I'm going to go over my object right here. So it's an object named class 1, very descriptive name, I know, and we're going to notice some pretty interesting things here. So this is just our shorthand getters and setters, and notice how there's no constructor. Our constructor is just automatically defined by the compiler, so we don't have to worry about that. We can access these variables outside of this here class, and the reason we can do that is because of the public decorator slash keyword here. So public integer ID, public integer number, and then a public string description. And it just uses system, but we don't actually use this within this class because I'm not using any function of system. So this is a pretty neat feature of the list as well. Right here we're taking a list and creating a list of type class 1, and this is FCL, first class list, because I named it first class earlier, and the other necessary code to initialize this list. And in here we can add class objects, and let's look back a little bit and think to where we can apply this. So right here, of course, you might be thinking, why would I create a list of type class? Why don't I just use a dictionary? Why don't I just use JSON? Well, we get to utilize some of the nice functions of C#, which are typing. So we can make this here a nullable integer. We can make this a nullable string. If we try to pass in a value that's not going to fit into this list, it's going to throw an exception, and it's not going to store that junk data. And where this might be applied is if there's a financial institution and they get some junk data, but I should probably go into a little bit more detail here. They get passed in the right ID for an account. They get a key that is junk, and for some reason they have some bad logic, where the key that's being used to, think about it, unlock the account, the key to, unlock the account and access the funds, you pass in that junk data, well, now you compromise the security of that account. So if we can stop that at the exception and handle that with a try catch and just end the process right there, we just stop some fraud, or we stop some issue that's going to cost somebody a lot of money, which is good. So that's where that can be applied. This here list, though, we're going to add some new objects to this list, first, second, and third, with some different IDs, and then we're going to try this here operation. So we're going to create a new object, a new class 1 object, and that's going to be set to the output of this here function, first class list dot first. So it's going to return the first instance of this here, where the object.id is equal to 1. So let's think about this for a second. Where is any of these objects, where is the ID equal to 1? Well, it's right here, where the description is equal to first. And we're gonna write down the value of the description for this object. So why don't we just try stepping through this. If we look here, the value of this here object that we created, the description value is first, because the ID is equal to 1. It meets this here criteria. And we're going to print that out. And exactly as we would expect, there's the description. we're not going to go through this catch, of course, because we don't have any errors. So I understand that this video may have been a little bit rushed, but it's just the basics. It's just the basics of C#. So we'll get a lot more familiar with a lot of these here parts of C#. Maybe you haven't seen them. They're used extensively, and a fundamental knowledge and understanding of these here concepts is integral to your success with .NET development. So make sure you review this video. If you ever have an issue in the future, just go back to this video and go over your syntax here again, because like I said, it's going to be paramount to your success. So the assignment will be posted. If you have any questions, just send me a message on Discord. But other than that, thank you for watching.